concept of refueling an electric car at home is oh so simple, at least in an ideal world. You plug it in at night, just like you would a mobile telephone, and then you let the car suck on the sweet, sweet electrons flowing from the wall outlet or charging station into its battery pack. Get up in the morning, and unless you've been charging your car from a really low power outlet, the battery pack will be full, ready to take you wherever you want to go. Except in the real world, charging your car is a little more difficult. And I'm not talking about those of you who don't live in a house with an attached garage or have an easily accessible wall outlet nearby. I'm talking about rapid charging your car at a public charging station. The methodology is the same. You plug your car into a rapid charging station and then you let the car charge. But the reality is different because right now there are many different rapid car charging standards out there. Each is different and each can be used with a different type of car. And while I have made some videos on rapid charging before, the increased number of people I'm seeing on a weekly basis try to plug car A into rapid charging station using plug B tells me that there's a lot of confusion. Of course, one solution to this all is the excellent ChargeWay system as described by Matt Teskey of Teskey Design in this video. I'll link to it in the show notes. And while there will be people who arrogantly respond to that video by saying things like, "It's obvious, why are people so stupid? It's clear how everything works," I'd counter with one simple question. What does implementing a system like ChargeWay do to inconvenience people like you who already understand charging? I suspect the answer is nothing. But that's not the purpose of today's video. Today's video is intended to focus on where we are right now, explaining the different connectors and explaining the drawbacks and benefits of each charging system. First up, CHAdeMO, the first modern electric car rapid charging standard that enjoyed high adoption rates. Originally designed in Japan, CHAdeMO, which is a pun on a Japanese tea joke I'm not going to explain here, was adopted by Mitsubishi, Nissan and Kia as the chosen direct current rapid charging standards for their electric cars. Early CHAdeMO charging stations were generally designed to deliver between 25 and 50 kilowatts of power direct to an electric car's battery pack, allowing the Leaf's 24 kilowatt-hour battery pack to be refilled from empty to 80% full in about half an hour. Despite charging stations and cars only generally maxing out at 50 kilowatts though, CHAdeMO's first iteration was capable of a higher power transfer rate, but it was rarely implemented in the real world. CHAdeMO also has another neat trick up its sleeve that other rapid charging systems don't yet have: two-way power transfer. This has paved the way for vehicle-to-grid capable projects where power is stored in an electric car battery pack that can be used to power a home in a power cut or even feed power back to the local electricity grid to provide power smoothing. Still in its early days, such systems are now popular in Japan but have yet to gain popularity elsewhere. It's also the reason, by the way, why the Toyota Mirai and Honda Clarity fuel cell vehicles in Japan have onboard CHAdeMO connectors, allowing the cars to provide backup power in an emergency to homes and businesses. The latest version of CHAdeMO, CHAdeMO 2.0, supports power transfers in excess of 450 kilowatts, allowing for far faster charging times. It also implements a whole lot of new vehicle-to-grid capabilities and even adds a way for charging station manufacturers to identify a vehicle when it plugs in, eliminating the need for RFID tags at charging stations. If you have a Nissan or Mitsubishi electric car with quick charging, it's the CHAdeMO charger that you're going to need to use to refuel. Kia Soul EVs also use this connector, but newer Kia models have switched to CCS, which brings me to CCS, or Combined Charging Standard. Designed and adopted by a consortium of European and automobile manufacturers from America as the chosen standard moving forward, its design allows for one single charging socket for both rapid DC and slow AC charging by using the local low power charging socket as its base, then adding two high power prongs beneath. Because the US and European slow charging plugs, J1772 and Type 2 respectively, are different in their design, there's actually two different CCS plug designs, one based on the US plug and one based on the European plug. And if you're already confused, as I say, go back and watch that ChargeWay video to see how simple it could be. Early CCS charging stations deliver between 25 and 50 kilowatts on average, but the newer stations can deliver up to 150 kilowatts. There's also a next generation higher voltage CCS rapid charging standard developed for cars like the Porsche Taycan and next generation high power cars from Audi, Volkswagen and others. This will handle upwards of 350 kilowatts of power, putting it in line with Tesla's supercharger technology, which I'm going to deal with next. Unlike CHAdeMO, however, CCS can't yet be used for two-way power transfer because the standard hasn't been agreed on. CCS was initially far less common in the wild, but thanks to legislation in both North America and Europe, we're now starting to see CCS become the dominant charging standard. Next up, let's deal with Tesla's supercharger tech. Technically open source, but since nobody has opted to take Tesla up on its offer of sharing the tech quid pro quo, it's proprietary. Tesla's superchargers are essentially only available to Tesla cars made from 2012 onwards. Originally capped at about 100 kilowatts of power, superchargers have become more and more powerful over time, with today's highest power superchargers offering around 145 kilowatts of charging at max draw. Unlike other charging stations of other standards, Tesla superchargers have traditionally been installed in groups, ensuring that even if there's a technical fault with one station, a driver can just refuel using another. Originally available free of charge on an unlimited use basis, Tesla's supercharger network is still the king of electric car rapid charging when it comes to reliability and coverage. But like CCS, there are actually two different supercharger connectors out there. In the US, Teslas use a Tesla-designed slim connector for both low and high-power charging. In other parts of the world, Tesla used a modified version of the Type 2 connector used for low-power AC and high-power AC charging. Slightly longer than the standard Type 2 connector, this has led some people with electric cars that aren't Teslas to erroneously think they can charge at Tesla supercharger stations, resulting in the cables getting stuck in their cars and a rather embarrassing call being made to Tesla to ask for help. And if you're confused, it's simple. If your car isn't a Tesla, you can't use a Tesla supercharger. So far, we've covered three main types, and if I'm honest, CCS and Tesla supercharger seems to be winning in most of the world, despite CHAdeMO being a personal favourite of mine because of its capability to transfer power bidirectionally. But there are two other connectors you might just run into. The first is the GBT connector. However, this connector only exists in China, and while it's mandated for all Chinese EVs, including Teslas, for DC charging, I'm guessing the likelihood of you finding this in the wild outside of China is zero, so we'll ignore that. The only other one is the AC rapid charging standard used by Renault for its electric cars. Like the European Tesla connector, it uses a Type 2 connector to transfer power quickly, but it can only be used to rapid charge Renault cars. Again, if you're at a rapid charging station and you don't own a Renault, don't use this plug because you will not be able to charge with it. So that's it. Those are the charging plugs out there that you're likely to see for rapid charging. Which do you like and why? And have you ever seen anybody try to use the wrong connector to charge their car? What happened? Leave your thoughts and stories below. That's it. Thanks for joining me and see you next time.